Another type of reaction is combustion reaction, a type of redox reaction. In combustion reaction, a compound combines with the oxygen to produce some products along with some energy. Sometimes it produces flame, sometimes it will not produce flame. So what we are trying to explain here is the combustion of hydrocarbon, a subset of combustion reaction. So hydrocarbons are a compound containing carbon and hydrogen. So we can say carbon with certain number of carbon atoms and hydrogen, certain number of hydrogen atoms combines with oxygen. There can be two types. Either it can give you carbon dioxide and water, or it can give you carbon monoxide and water. So that depends on complete combustion and incomplete combustion. So incomplete combustion means it will have sufficient amount of oxygen to combine with, whereas in incomplete combustion, it will not have enough oxygen. So in that case, it will produce carbon monoxide. If it is complete, it will give you carbon dioxide. So we are talking about the complete combustion and how to balance those types of combustion equations. So that means suppose CxHy combines with oxygen will give you carbon dioxide and water. These are the types we are going to discuss. How to balance this one, and take an example of CH4 plus oxygen gives you CO2 plus what? So complete combustion always gives you these two products. You have to remember that. So carbon combines with oxygen to form carbon dioxide and hydrogen combines with oxygen to form water. So first let us balance carbon. So carbon, how many we have in CH4? We have one carbon, and in carbon dioxide we have one carbon. So carbon is balanced. Then I will look for hydrogen. I have 4 hydrogen on the left side and I have to make 4 on the right side as well. So we can put a coefficient 2 here in order to make 4 hydrogen here. So carbon is balanced, hydrogen is balanced. Now look for oxygen. So we have 2 oxygen on the right side with the carbon dioxide, and we have 2 oxygen with the water. So total we have 4 oxygen atoms. So on the left side we have only 2 oxygen atoms. So we can add a coefficient 2 to get 4 oxygen atoms on the left side as well. So we have balanced that one. So the coefficients are 1, 2, 1, 2. So now we have a balanced equation for this complete combustion reaction. Now let us say another example, which is having little more carbon atoms. So let us take an example of C3H8 combines with oxygen. So this is also hydrocarbon. So I know the products are going to be carbon dioxide and water. And now I will see how many carbon atoms on the left side. I have 3 carbon atoms on the left side. So I will make 3 on the right side by putting a coefficient of 3. So on both sides I have 3 carbon atoms now. And now I will look for hydrogen. I have 8 hydrogen here. I have only 2 hydrogen on the right side. So to make 8, I need a coefficient of 4. So now I got 8 hydrogen atom on the right side as well. So now look for oxygen. I have 2 oxygen atoms on the left side, whereas on the right side I have 3 times 2, 6 oxygen atoms from the carbon dioxide side and 4 from water. So that means total 10 oxygen atoms. So how can I make 10 oxygen atom on the left side is by putting a coefficient of 5. So I have a balanced equation for this hydrocarbon. Another example now. Let's take an example of C4H10. So C4H10 combines with oxygen and it will give you carbon dioxide and water. So how many carbon? We have 4. So I have to put a coefficient of 4 here. And then how many hydrogen? I have 10. So put a coefficient of 5. So 5 times 2 will give you 10 hydrogen atoms. And now look for oxygen. So 4 times 2, 8 oxygen atoms here and 5 oxygen here. So 8 plus 5, I have 13 oxygen atoms on the right side. So how can I make 8 13 oxygen on the left side. So I have already 2. So which number multiplied with a number that will give you 13 oxygen? So I have to go with a fraction, which is going to be 6.5 here. That means 13 divided by 2, that will be 6.5, right? So because I already have 2 oxygen here. But we normally don't put fractions in the equation. So I have to make it as a whole number by multiplying the whole equation with the 2. So that means all the coefficients I am going to multiply by 2. So here nothing means by default it is 1. So 2C4H10, 6.5 times 2 will be 13 oxygen, will give you 8 CO2 plus 10 water. That is how we have to write in this case. Okay, so we can see more examples. So here is the example with the more carbon atoms and hydrogen atoms. So the example I'm going to take, C8H18 combines with oxygen and it will give you carbon dioxide and water. So let's see how many carbon atoms here, 8. So I have to make 8 on the right side as well by putting a coefficient of 8. Then I'm going to look for hydrogen. I have 18 hydrogen. So 9 times 2 will give you 18 hydrogen. So those things are simple. Now let us go ahead and look for oxygen now. So 8 times 2, so I will have 16 and I have 9 here. So it will give me 25 oxygen atoms on the right side. So how can I make 25 here? The easiest way is to make the fraction. So I already have 2 here. So 25 divided by 2, that means 12.5, or we can just write 25 divided by 2. Okay, so but I cannot have fraction. So what I will do, I will multiply the whole equation by 2. So what I will get is 2C8H18 and 25 by 2, 25 divided by 2 times 2 will be 25. Oxygen will give you, and now multiply coefficient A by 2, that means 16 CO2, and 9 times 2 will be 18 water. So that's how we can balance the hydrocarbon with oxygen. If we are getting a fraction for oxygen, we will just do the fraction first and then we will make it whole number by multiplying with the number with that makes it whole number. Okay, in both examples we have done, it's easy to multiply with 2 to get the whole number, so we did that one. Mostly it comes like that. Now let us try another example, that is with the sometimes compounds will have oxygen also involved in it, like ethanol. It can also combine with oxygen, and in this case also we are going to get carbon dioxide and water. So let's see how can we balance this one. So in ethanol we have 2 carbon atoms, so we have to make 2 carbon atom on the right side. And then I will look for hydrogen. I have 5 hydrogen here, 1 hydrogen here. So total 6 hydrogen atoms on the left side. So I have only 2 hydrogen atom on the right side. So how can I put a coefficient 3? So I will have 6 hydrogen atom on the right side as well. So carbon and hydrogen balanced. So that's the order I will go. First I will balance carbon and then hydrogen. And now look for oxygen. We have 1 oxygen here and 2 oxygen atoms on here. So that means total 3 oxygen atoms on the left side. So how many on the right side? I have 2 times 2, 4, and we have 3 oxygen here. So 4 plus 3, total 7 oxygen atoms on the right side and 3 oxygen atoms on the left side. So how can I make 7 on the left side? So what I will do is I will add a coefficient of 3 here. So it will become 6 oxygen and 1 oxygen from the ethanol. So total I have 6, 1 plus 6, that is 7 oxygen atoms on the left side as well. One more example with a compound with the oxygen atom. So let me take an example of C3H7OH. When it combines with oxygen, we will have carbon dioxide and water. So I have 3 carbon, so I will put 3 here. And I have 7 plus 1, 8. So I will put 4 here. And now I have 3 oxygen atoms on this side. And I have 6 plus 4, 10 oxygen atoms on the right side. So if I have 9 oxygen atom here, I have 1 here. So total I will get 10. So how can I make 9 here? So since I have 2 already here, I need 9 divided by 2 here. That is a fraction. I cannot keep that fraction. So I will multiply it by 2. So I will just write 2 C3H7 OH. So this will be 9 oxygen. That will give me 6 carbon dioxide and 8 water. So let us see. I have 6 carbon, and I have 14 plus 2, 16 hydrogen atoms, and I have 8 times 2, 16 hydrogen atoms, and I have how many oxygen? 2 and 18, so total 20 oxygen atoms, and here are many? 12 and 8. So 12 plus 8, I have 20 oxygen atoms, so it is balanced. So that's how we will balance the combustion reaction. And we actually discussed 2 types here, hydrocarbon and some compounds containing oxygen atoms. So that is alcohol, we took examples. I hope you have an understanding of combustion reaction balancing equations now. Thank you.